Today we're diving into the step-by-step process of creating this highly precise sheet metal part from initial design all the way to a finished part and every step in between. I hope you enjoy. Let's get right into it. So the very first step in the process of designing any stamped part is going to be creating it in some type of CAD software. So that's what I'm doing right now. I'm creating this very unique profile in AutoCAD. Now, AutoCAD is really good for two-dimensional sketches. If you're using three-dimensional, SolidWorks would be much better. So after the design process, we're going to get to work and start wire cutting some of the components. We're going to need to cut a punch, a die, a punch holder, and a stripper. And just to let you guys know, we're not building an entire progressive die right here. We're just building one station within a progressive die. So our fabulous wire operator, Luke, is getting it set up. He's threading the wire in the hole, filling up the tank, and doing some programming and setup. The wire machine will fill up with deionized water. This happens to be a submerged wire machine. There's also non-submerged wire machines, but flushing is a super crucial element for the wire EDM machine, so a submerged machine is going to be better. This is the program of the part that we are cutting today. And after about an hour and a half of cutting, we have a finished punch. Now we're going to be making the dissection, and we're going to have to add some holes into the dissection because we have some pilot holes, and we have holes for the dissection itself and some start holes. So this machine is called an EDM hole popper, if you don't know. It uses a pulse of electricity sent through an electrode to essentially burn through the metal to make a hole. This is a super important machine for us, and it does save a lot of time and headache. Now the 5 holes are finished, and as you can see, they're pretty small. They're about 25 thousandths in diameter. This will then get mounted in our wire EDM machine, and about 2 hours later, we have a finished part with a couple of pilots, the center dissection, and it'll also cut the outside. And this is the bottom of the dissection. This is the tapered end where the slug gets pushed through into the die set. And this is the other side. This is the actual cutting edge where the punch will enter. And you have a couple of pilots there. What they do in a progressive die is locate the strip in the proper location from station to station. Now we're going to take the punch over to our bead blasting cabinet and clean it up. Bead blasting is basically like sandblasting. It's just the media is a lot less aggressive. and you can see that the punch is not totally clean. It needs to be cleaned up, and after bead blasting, it'll have a nice finish. As you can see, it looks a lot cleaner. And now I'm ready to grind the punch up, grind the tab off, and grind it to size. Now we're going to set up the surface grinder to grind off the tab on the punch. Punches have tabs because they need to be held in the block to allow the wire machine to cut multiple passes on the punches. Right here you can see is the tab. You can see it right there. Now I'm going to place it on the magnet. There's not a lot of surface to hang this punch on, so it kind of looks awkward. It's hanging off the end of the magnet. And I have a couple thin shims that are going to hold it in place, but usually I don't have, this is kind of an odd shaped punch, so it looks kind of weird hanging off the end of the magnet, but it kind of is what it is unless I make a special fixture for it. Now we're going to start grinding the punch, grinding the tab off. I'm going to be taking about 1/10 passes off of it. If I take any more, it will heat up, and that is probably the worst enemy to a surface grinder is parts that are heating up. You always want to keep parts as cool as possible to prevent distortion and warping. I'll measure the part and see where I'm at and take the remaining material off. Because the tab was so close to the edge of the part, I was afraid of nicking it, so I stayed a little too far away from it, and there's still a little lip that I left on there, so I'm going to have to put it back in the surface grinder and grind off that little bit of a lip. measure it with my micrometer again, and this time it looks perfect, right on the money at 30 thousandths of an inch. Now we're going to make the start holes for the punch holder and stripper. It's going to look very similar to the dissection if you look at it, except it's going to be longer, and it's also not going to have taper. The punch holder does exactly what the name says and holds the punch, and the stripper actually guides the punch into the dissection, so you have very good alignment, and also strips the material away from the punches.
Goes back down.
And here are the finished holes. Here we'll mount it up in the wire machine again.
I'll do everything.
Fill up the tank, begin cutting, and a few hours later, we'll have a finished part. Now I'm going to measure the frame cavities so I know exactly the right size to make these inserts, and I'm going to do that with gauge blocks. A bit too tight. I need it to be a little bit smaller. That's the fit that I'm looking for. Now I'll measure the other side of the frame cavity. That fit looks pretty good. Now I'll measure the gauge blocks and write down the size. I bead blasted the punch already, but now I need to bead blast both inserts. Just like the punches, these also have tabs on them, but both of these have 2 tabs each, and now I'm going to grind those off. Now I'm going to square up the front surface so it's nice and smooth. I have a nice ground surface. So when I bring it over to a machine called the Optical comparator, it has a very accurate edge to read off of, and I can be very accurate in my measurements of putting it on center. I'll take it out of the vise and give the edges a nice stoning to deburr them. And then I'll run the punch in through the dissection to kind of clean off the burr so I can read it very accurately on the comparator. Now this is an optical comparator. It is a device that uses light and lenses to magnify and project an image, usually a small one, to a screen, allowing for very precise measurement. So right now I'm going to be taking precise measurements of the internal cavity and taking notes of what they are. I'll write them down and then I'll bring the insert over to the surface grinder and attempt to bring the cavity within 1/10,000th of an inch on center. Now that that tedious back and forth process is finished, I'll double check with the micrometer and everything looks good. Now I'll just break the edges. And the reason why I have to break the edges is because the frame cavities have very small radiuses on them, and if I didn't do that, they wouldn't fit inside. The inserts get clamped down into the frame cavity, and right now I'm just going to make the slots for those clamps. Demagnetizing the insert. So right now I'm going to install the dissection into the progressive die. Right now I'm going to be indicating the punch holder slash stripper to make sure that it's totally square from side to side. I'm also going to check to make sure that it's parallel on both sides of the block, on both faces of the block. And I'm going to make sure that it's perfectly on center as well. This indicator is a 1/10,000th of an inch indicator, meaning every line is 0.0001 of an inch. positive 2/10. Let me see what the other side is. It's negative 4/10. So it means I have to take off about 6/10 off of this side. So it looks like I have about 6/10,000ths of an inch to remove off of one side of the block, so I can put the configuration on center. So that's what I'm doing right here with the surface grinder. Now after taking that small cut on the surface grinder, I'll just double check to make sure that the part is 0, 0 now on both sides. And it looks really good. Now that I'm perfectly on center with the cavity, I'll take a measurement and then take even cuts off of both sides until it fits perfectly in the frame cavity. And then I'll rinse and repeat and do that same thing with the other side of the block. After that, I have a few minor details to finish, such as grinding the blocks to size, cutting them in half, adding some clamp slots, and some other small details to make everything fit together very nicely. Right here is a stripper insert, and the purpose of this particular stripper insert is to strip the material off of the punch when it runs in the progressive die, and to also guide the punch properly into the dissection. And we have to break the edges so the punch can enter properly. Right here, I'm installing the punch holder into the die. And now the stripper insert goes into its proper place. Right here we have the progressive die, and on the left side here is the upper half, and on the other side is the lower half. And right here I'm just gonna put the die together and put it into the press. Right now the progressive die is being installed into one of our many 30-ton Brooder punch presses by Sean. He is going to get this thing nice and square with the punch press and bolt it down very secure so we can run some parts. Now Sean is starting to run the strip through for the first time, and as you can see, he's going very slow. That's what you have to do the first time when you run a strip through. You have to take a lot of care just to make sure that the strip is going where you want it to and it's properly piloting. Now finally, all the hard work we put into this die, we finally have a finished part, and here it is. A die like this will actually produce hundreds of thousands of these per day when it's running at full capacity. Right now, I'm just showing you the first part that's coming off of the press. Very shiny, nice, clean, burr-free part. If you guys made it this far, thank you so much for watching. See you in the next video.